kind of got a picture in my head, which I think is a good analogy, right? So if we take the simple version of an apple falling from a tree to the ground, you know, do you remember those penny machines where you put a penny in and it can go down a whole bunch of different tracks, right? You got the nails in it. Someone did right. They're crazy but fun. Someone did a computer program where you could play around with that and you know, have X number drop from here or draw from here, drop from here, and it would model how many went everywhere. But eventually there were patterns. And I played it out in various iterations just to think, if I ever do go and play one of these machines, what's going to be the best possible like slot to put it in? And it worked out that the largest amount would always collect in the middle section, right? So,
ever heard of Pascal's triangle? That's what it is. So Pascal's triangle is a 1, 1, 1, 1, 2, 1, 1, 3, 1, 3, 3, 1.
Right.
1.
Yeah.
So, and the reason those numbers because the way they add together, but the numbers are larger in the middle. So by the end, it's like 1, 4, 6, 6, 4, 1 or something, and then so it'll land 6 times at that spot and only land one time at that spot. End. So it's actually a probability tree. For Plinko. So if you always drop it at the top and it does that, it'll, like you said, it'll land in the middle. And it has to do with normal curves and probability. And
but there's a definable rule.
For sure. Yes, it is. It's not just kind of totally random.
Because that's how it appears when you play. It's just like I have no idea where it's going to go.
But there's a probability to it. And I think there's definitely a probability working out here as well. And it has a lot to do with like quantum mechanics is probabilistic as well. I don't know if you're familiar with it, but you know, there's this kind of debate. You know, is everything calculable, or you know, is it completely like random or something? And the Einstein view was that everything should be deterministic and calculable.
Right.
And then the quantum mechanics guys came in and they were like, well, it's actually all probabilities. So you know, we can be, you know, 50% sure this will happen, or 80% sure, whatever.
Given what we know.
Well, given like very accurate like equations.
Okay.
And it's actually built that way. It's not just given what they know. It's like caked into the system.
So tell me more about that.
Well, it's just to say that just imagine a probability is not just a function of how much that you know. It's like it is part of the system. Like you can know everything and it'll still be probabilistic. You see what I'm saying? Like, you know, even if you know everything, you still can't predict 100%. You have 100% of probability. You know 100% what the probability rules are. In the same way that Pascal's triangle, we know 100% what those probabilities are.
But we
can't say for sure it's going to land there. We just know
it's going to be more likely or less likely. To a degree.
Sure.
Right. So
it's like caked in.
So we say that everything we learn is likely to be true up to this percentage. Kind of like this is the most probable solution or answer or you know.
So just to go back to what we're talking about is that, you know, the patterns are also going to have this probabilistic, you know, piece to them, where, you know, you can know everything about the patterns, but it'll be like we were saying yesterday with the points, you know, like we'll know that there's 8 things around us related to this symbol,
but we won't know
pattern.
Which.
We won't know exactly maybe which. We'll know maybe, you know, like
so we could say 80% chance out of using Apple as the example again, that 80% chance of one of the 8 things around us is going to be an iPhone. And one of them is going to be a MacBook, or, you know, whatever.
So and it's like this reflection rule. So I think that's where the probability comes in, because the physical world is a reflection of this abstract world, and so it doesn't reflect perfectly. You know, it's not. It just gives you like an equilibrium. It gives you these probabilities of things appearing based on your position within all of these patterns that are around you.
Is it because that our reflection isn't perfect? It's different. You know, it's a different manifestation that we need probability to kind of. It's our way of resolving, or part of the way of resolving this reflection.
Yeah.
Or is it like a fundamental cause? Is it like written into that computer code that we're talking about, or that language behind everything?
Yeah, well, I think like Pascal's triangle is written into it. Like I think it goes very deep because it's a hierarchical tree.
Yes.
It's actually a hierarchical pattern.
So it's those two things already.
Yeah, so
Yeah.
Pascal's triangle is actually like the base. Is kind of like a way of looking at a hierarchical pattern, and hierarchical pattern is one of the 5 patterns of the abstract space. The other things that to consider is that the abstract space and the physical space are actually like one. Like it's one space, but they're like split apart at some point. There is a difference between the two, and there is a reflection between the two, but it can be combined into one.